everyone. I'm Lindsay Slavin. I'm coming to you from Jupiter, Florida, like a completely other planet from here. Like Jeff said, my dad was here in 1973, almost 40 years ago. It seems pretty old to me now. And my brother was here last year, and I'm so lucky to have been fortunate enough to be able to do this experience. I've had the opportunity of a lifetime. So I came here and I knew absolutely nothing about rocks or glaciers coming from Florida, like I told you. And so I was really just looking for a great experience, and I met up with a PhD student, Seth Campbell, coming from Maine, and he got me interested in rocks. So that is what I ended up studying this summer, and I used the GPR machine like the other students presented earlier. So you've seen many maps today. Oh, laser pointers are cool. And we started off in Juneau here, where we are now, and we skied up to Centurion Ridge. That is west of the Taku Glacier, which you can see more specifically here. And that is where I used the GPR machine. Keep it moving here. So this ridge here, I hiked up to. It was nice to do that. We started over here, and Seth and I took the GPR machine, and because we had to hike up here, I actually got to have the privilege to tie it around my body and drag it behind me like a pack mule. It was very difficult. I fell in a few holes and tripped a few times, but I dragged it all the way up and over this ridge. And we marked it every 10 meters to look at the bedrock underneath the snow and the rock. And pretty much my main goal was to see if it was possible for the GPR machine to pick up on bedrock features. And I'm going to keep showing you. This is just another picture of the ridge, and we went over these rocks actually with the sled behind me, which was just a trip. And we went all the way up here. Like I told you, I've never hiked before, backpacked before, anything, so it was a hoot. Okay, so this science-looking image here, it looks as new to me as it does to you, trust me. Like Annie said, I do like to call it the zebra thing. I mean, these stripes here just resemble a zebra. And what this means pretty much is the GPR machine makes this image on the computer, and it's the profile of the bedrock beneath the ice and the rock that I'm dragging the sled on top of. And supposedly, according to Seth, he taught me, I'm going to try to enlighten you all, that when it goes black, white, black, or white, black, white, it goes from a lower to a higher density, which would probably indicate there's water inside of the bedrock, which would then indicate that there is a joint or a fracture in the rock. So that's just a cool fact for you there. And then another profile, as we continue to move forward, is going to be pretty difficult for you. It's difficult for me as well. If everyone kind of tilts their head a little and squints, you may see a fine line right here. I didn't pull it out. I mean, if I pulled it out, I don't even know how I'd be able to do that, but Seth told me that there's a line right here. This line, we're pretty sure, is this rock contact. I did learn what a rock contact was this summer. That's when two rocks supposedly come together, and the rocks are different types of rocks. And I learned that this light color right here is granite, and this darker one right here is called a diorite, actually, which is a deeper colored, intrusive granite. Woo! Anyway, so we're hoping, not positive, that this line right here, again, we need to squint all together now, that line is the contact. So, in conclusion, everyone, I came here knowing absolutely nothing, and I'm giving you a presentation right now trying to teach you about it. And it's not too easy for me, but what I can tell you is that my scientific question was, like whether I could identify bedrock features using the GPR machine, and I was successful in doing that. So that's really great, and I need to further process the data with Seth, the expert in Maine, because he's going to help me accurately identify what the features are, because I can't do that yet by myself. So yeah, I really had a really great time. I love rocks, look how happy I am there. And thank you so much for the experience, everyone.
Hey everybody, my name's Erica. I just recently graduated from Cornell University in upstate New York. This summer what I spent my time doing, besides skiing around and everything, looking at some temperature data. So you've seen this map a bunch of times already. These are a bunch of the camps we stopped at, plus a few more. I was looking at as many as possible to do as much analysis as possible, both spatially and temporally. So what that data looks like is a little frightening, but these are all the camps. As you can see, they have this big wiggle going on each year. Higher temperatures during the summer, colder temperatures during winter. But basically, the first time I looked at this with Brad, who you mentioned before, was my advisor, we figured I'm not really going to get much from this other than that you can tell this is the Juneau Airport data. It doesn't get quite as cold in the winter as everywhere else on the ice field. But so what the first thing I did was to remove this seasonal signal so we can get an idea of what interesting things might actually be going on. And what happens when you do that, you get a totally different graph. This is temperature anomaly on the side. Basically, to do that is you average all the temperatures in every January data set at one camp, and then subtract it from each data point, and you get just the anomalies and totally remove that seasonal signal. So what I'm still working on is trying to figure out what all these squiggles might mean and what interesting things might be happening. One of the things what I've done so far is looking at this spike here. This is November 2006. We have this huge downward anomaly, and then in December and January it goes right back up above zero. So another spaghetti like Lauren showed you earlier. We have, these are, like Lauren said, these are back trajectories of air masses coming through. So I used Camp 9, and as you can see, we have a lot of air coming in from the north during that big cold spike, whereas in December and January we get a more normal looking spaghetti with everything coming in across the ocean. So what I'm hoping to do over the next few weeks is trying to figure out maybe why here's warmer versus here. I'll also be comparing it to El Nino and everything. But I'm pretty excited to figure out what the heck is going on at Camp 29 right there and everything like that. So thanks.